Okay, let's take this a little bit further. I will draw two curves in Rhino and divide them. That's one. That's two. And I will divide them both into, say, 20 points or 20 segments. So now we have all of these points as Rhino objects. And I can go into point parameter A, and this time select multiple points. And I will select all the points which are part of the first curve. And now they're all referenced as point objects. I can do the same for this one. Set multiple points and select from the top. There we go. And now we have 21 points in A, 21 points in B, and 21 lines as an output. However, this is of course quite manually work intensive. I have to actually select all the points by hand, make sure they're in the right order, and if I change it, I have to go back and select them all again. So this is not a very efficient way of making an algorithm that generates lines between two curves. Instead, what we will do is we'll actually mimic the divide curve command in Grasshopper, so it's all automated from the start. Let us delete this, delete all our points, but not the curves. Delete, delete, delete. And now the purpose here is to actually perform the divide command inside Grasshopper. If you don't know where to find components, which is quite likely if you're just starting out, you can always double-click on the canvas and start typing what you're looking for. And there's a lot of components which have the word divide in them, but looking through this list, you typically find what you're looking for reasonably quickly. Sometimes, of course, you don't even know the name, and then you have to actually start searching through the tabs. But for divide curve, it's fairly obvious. So divide curve into an equal length segments. Okay, that's the one. It's a bit more complicated than the line component. This one has 3 inputs and 3 outputs. Though, of course, at first the error or the warning is the same. It says that input parameter C failed to collect data, so there is no curve to divide. If you hover over a parameter, it'll tell you what this parameter is for. In this case, it asks for the actual curve. The N input asks for the number of segments, and it actually has a default value of 10. And the K input is a setting that tells you whether or not points will be added on kinks in the curve, and its default is set to false. So let us go in here and set one curve. And it will import a curve from Rhino. Now these points are actually live. So if I change the curve, if I change the control point or the shape of it, it actually updates those points. So this is now no longer, we no longer have to go in and select them by hand later. Let's do that again. This time I'll make a second completely separate component for the second curve. But it's the same steps. Open a menu and set one curve. And now we have 2 separate curves, which are divided into 2 separate points. In addition to the points, which are the output here, we also have the curve tangent vectors. Basically, for every point here, we have a little tangent vector that tells us where the curve was traveling at that location. We can't see the vectors here. They're not previewed, but they are there for our available for our use if we want them. And we also get curve parameters. And a curve parameter is a number that tells you how far along the curve this point happened. So the first one was at 0, which is probably over here. Then it was at roughly 10, then roughly 25, and so on all the way down to the end. We can use these numbers later if we want to evaluate different things about the curve, for example, curvature or torsion or some other property. But for now, we will only use the points. I'll make a new line component between 2 points. And this time, instead of setting points directly inside these input parameters, I will inherit data from these parameters. So these point outputs are shared with this point input, and these points go in there, and then we have 11 line segments as a result. These things are called wires, and they always connect one output with one input. You cannot select, or you cannot share inputs with inputs, that's not allowed, or indeed outputs with outputs. And if you try and make a loop of wires, so if you try and take this output and put it back into an input, it will fail. It will say that this algorithm is recursive and we cannot solve this at the moment. So it's always stepwise from left to right, and you can never go back to earlier components. If I want to change the number of divisions here, I can go into the n input and pick a different number, right? I can go in here and say, well, let's go for 20. And go in here as well and say 20. And that's actually quite annoying, that I have to make sure that this n and this n have the same value all the time. It always means my work is doubled. The way to solve this is to make both inputs depend on the same value. For example, I can take an integer parameter, which is just a single, just a number. It doesn't actually make anything new like these components. I can say in here, well, this is now 30, and please share this number with both inputs. And now if I change it here, it changes everywhere at the same time. Even better would be to use a slider to control this. If this is a number that is not absolutely fixed and it might change over time, I can use a number slider to very quickly change the number of divisions. Now by default, a slider goes from 0 to 1, and it has 3 decimal places. But I can change it to work only on whole numbers. So instead of working on floating point numbers, it works on integers. And it can go anywhere from between 1 to, say, 100. So now we have 1 as a minimum and 100 at the maximum. And now I can change it completely in real time as I see fit. Okay. Are there any questions so far, Mary, about what I've shown? Or is this making sense to people? Yes. There are 2 options which are enabled in my Grasshopper, which might be disabled for you. If you go into the display menu, then you can switch between the icon view or the text view. So now we have text or icons. And furthermore, there's also fancy wires. These wires here are double, as you can see, which means that there's more than one item flowing from left to right, right? It's a list of items. Here there's only one number. Here there is 46 numbers. Unless you have fancy wires enabled, they will all appear as single wires. I would definitely recommend having this one enabled. Icons are up to you. That's a personal preference. If you want to give your components a special name, like if this is a very important line, say section line, you can actually give it a name, and that name will appear on the component. If you switch to icon view, then that is not possible. But I prefer icons. It keeps it clean and small.